Good morning to everyone. This is Dr. B. Polaiah, working as a professor in the Department of IT, the Institute of Aeronautical Engineering, Hyderabad. So today we extend to understand about definition and terminology, which are towards to concentrate on introduction to image processing and its. Let me have what do you mean or how to define digital image. An image is a 2D or 3D signal that can be observed by human visual system. It is called digital image. I repeat, an image consider either a 2D or 3D signal that can be observed by human visual system is called digital image. Digital image means represents of images by sampling in time and spatial domain is called digital image. I repeat, an image represented by using sampling in time domain or under space domain is called digital image. Digital image processing also perform digital signal processing operations on digital images. The field of digital image processing refers to processing of digital images by means of a digital computer or set of computer algorithms. The field of digital image processing refers to processing of digital images by means of a digital computer or a set of computer algorithms. The image processing is a method to perform some operations on an image in order to get an enhanced image or can extract some useful information from it. Is also concentrate in terms of image processing, where this type of signal processing in which input is an image and output may be an image or characteristics of an image which or represent features associated with that image. And also we have to know the major objective of an image processing is to transform an image into digital form and perform certain operation on it in order to obtain specific models or to extract useful information from the image. The original image which we defined in terms of either 2D and 3D images nothing but by the help of your characteristics only we used to define. So this we may suppose this is 2D. This is one is 2D image. So what do you mean this 2D image? That is nothing but two-dimensional. D means dimensional. An image is a two-dimensional. That why we also define an image as a two-dimensional signal. An image has only weight and width. An image does not have width. Just have a look at this image below. So as we have already seen that an image is two-dimensional signal, that is, it has two dimensions. It can be mathematically represented as f of x comma y is nothing but image, where x and y are two variables. The concept of two-dimensional and can also be explained in terms of mathematics by the help of f of x comma y of an image. Let us we take the three-dimensional signal. Three-dimensional signal as it means refer to those signals which has three dimensions. Another example of this three-dimensional signal is a cube or a volumetric data, or the most common example would be animated or 3D cartoon character. So the mathematical representation of three-dimensional signal is simply we says that f of x comma y comma z animated character, that is x, y and z is another axis or dimensions. Z is involved in a three dimension that gives the illusion of depth. In a Cartesian coordinate system, it can be viewed as three-dimensional in a three-dimensional. Let we going to have such a three-dimensional or two-dimensional in terms of adjacency. So what is the meaning of four adjacency and eight adjacency? So that is simply we say ND of P and N suffix 8 of P is represent, he is here, 8 is represent dimensional, P is nothing but your number of pixels in the image. That is, four diagonal neighbors of a P have Cartesian coordinates in terms of 4. That is, you see here 1, 2, 3 and 4 that are denoted by ND, that is N suffix D of P, which are represent number of neighbor. N means neighbor, D means diagonal, P means pixels of the image. So these points together with the four neighbors are called the eight neighbors of pixel P, denoted by N suffix 8 of P. So four neighbors is N, 8 is dimensional is 8 and pixels. If some of the points in the ND of P and N8 of P all fall outside the image if x comma y is on the border of the image. So we consider these three types of adjacency. Number one, 4 adjacency, number 2 8 adjacency, and 2 pixels P and Q with values from V or 4 adjacent of Q is in the set of n suffix 4 of P, and 8 adjacency is the 2 pixels P and Q with values from V or 8 adjacency if Q is in the set 8 n suffix of 8 of P. That is, M adjacency is mixed adjacency. M means mixed. 2 pixels P and Q with values from V or M adjacency is possible if Q is in n suffix 4 of P or Q is in the n dimensional P, that is ND of P, and the set whose values are from V. So different dimensions of the signals which we understand here. Let me see the one-dimensional signal. That is the common example of one-dimensional signal is a waveform. Simply we say this is one waveform. What is this? This is a waveform. This is on the x-axis and this is y-axis. The waveform is this. This is wave signal. So that it can be mathematically represented as f of x equal to waveform, where x is an independent variable since it is a one-dimensional signal, so that why there is only one variable x is used. So image sharpening and restoration is the medical imaging surveillance. That is what we want to understand here. The application of simple image processing, nothing but digital image processing, are number one, image sharpening and restoration. Number two, medical imaging. Number three, surveillance. Number four, law enforcement. Number five, artistic effects. And number six is mission or robot vision, and number 7 is color processing, and number 8 is video processing. As we are all aware about the challenges of digital image processing are not only these eight, but also unlimited challenges will be faced by the digital image processing in this today world. So you are all has to be understand towards to understand this most important point, which is even if you concentrate only medical image processing is different, surveillance is different, law enforcement is different, artistic effects is different, mission or robot vision is different, color processing is different, video processing is different. So such a inter or multidisciplinary application will be concentrated by digital image processing is one and one area and field help us to lead the technology towards to connect any discipline type of applications. Let us we take one example of image enhancement is here in terms of medical image processing. The medical image processing, which are computational processing technology or what we call as disaster management field of technology, also called. So this is medical, obviously X-ray. This is what we call is a computational process. Computational. Okay, this is one. This is two. Computational process, and this one is what we call disaster management. Disaster management, we simply call DM, field of interest. So one of the most common uses of this digital image processing techniques, only the important thing is one is improve the quality of visibility of the image and remove the noise, etc. So, for example, artistic effects which we concentrate here are used to make images are more beautiful, visualize, appealing, to add special effects and to make composite images. Next, the medicine, that is medical image processing, where we can take this take slice from MRI image. What do you mean MRI? M means magnetic, R means resonance, and I means imaging. Scan of a heart and find the boundaries between types of tissues. Number one, image, and number two, image with gray levels representing tissue density is using digital image processing. Use a suitable filtering to highlight edges is also used digital image processing. So next, as I said here, GIS, graphical information, that is a geographic information system, that is GIS. I'll write here geographic information system. So such a geographic information system is used in digital image processing in terms of extensionally or to manipulate satellite imagery. So terrain classification, meteorological application process we can understand. So I hope you're following these examples. One more example is law enforcement example. So especially the thumb impression is here today, and some traffic control system is also using this number plating and processing. Is used extensively by law enforcement. The number of plate recognition, the plate number plate recognition for speed cameras, automated toll systems, fingerprinting recognition by the help of your mathematical model of image processing. So next, another one is HCI, is a human computer interfaces for more natural processes that in terms of face recognition, gesture recognition. Does anyone remember that the users of interface from Minority Report? These tasks can be extremely difficult when we apply traditional way, but whereas in digital image processing is easy. I hope you are following that some of examples and coming to the field image processing here, computer graphics. Image processing is concentrating especially image enhancement, manipulation of an image, computer vision, that is the analysis of image content is called computer vision, which we can concentrate. The field of digital image processing refers to processing digital images by means of a digital computer. An image may be defined as a two-dimensional function f of x comma y, where x and y are spatial plane coordinates, and the amplitude of f at any pair of coordinates x comma y is called the intensity or gray level of the image at that point. When x comma y and the amplitude values of r, f are all finite discrete quantities, we call the image a digital image. So we can understand this in image processing in terms of defined components. That are components are where we build artificial image processing. Number one, image display. Number two, computer, mass storage, image processing software tools, specialization image processing, hardware copy, image sensors, and and solve your typically general purpose of digital image processing. So, what is the meaning of this image sensors are here? Two elements are required to acquire digital images. Number one, the first is the physical device that is sensitive to the energy radiated by the object we wish to image, that is sensor. The second, called a digitizer, is a device for converting the output of the physical sensing device into digital form. So specialization of image processing hardware usually consisting the digitizer mentioned before plus hardware that performs other primitive operations such as an arithmetic logic unit which performs mathematical nothing but arithmetic and logical operation in parallel on entire images. This type of hardware sometimes is called a front-end subsystem and is most distinguishing characteristics is speed. In other words, this unit performs functions that require fast data throughputs that the typical main computer cannot be handled in terms of simple hardware process. Whereas image processing software is nothing but consists of specialized modules that perform specific tasks. A well-designated package also includes the capability for user to write code that, as minimum, utilize the specializations of the modules. So we also define the mass storage capabilities in this. Mass storage capability is a must in a image processing application, and image of size is minimum 1 kilobytes of the pixels, that is 1024 into 1024 pixels requires 1 megabyte of storage space if the image is not compressed. The digital storage of the image processing application falls into three major principal categories. Number one, short-term storage during processing. Number two, online storage related to fast recall. And number three, actual storage characterized by infrequent access. Mass storage capability is also extended one more method providing short-term for storage in computer memory. Another is by specialized boards called frame buffers that store one or more images in that can be accessed rapidly. The online storage method allows virtual instantaneous image zoom as well as scroll and pan horizontal shifts. Online storage generally takes the form of magnetic disks and optical media storage. The key factors characterization online storage is frequent access to the storage data. Finally, actual storage is characterized by massive storage requirements but infrequent need for access. So image displays is also one more component of in digital image processing system, that is displays in use today are mainly color, preferably flat screen TV monitors. The monitors are driven by the outputs of the image and graphics display cards that are an integral part of a computer system. The hard copy devices used for recording images, including laser printers, film cameras, heat sensitive devices, inject units, and digital units such as optical and CD-ROM discs. With this, I want to close our video lecture discussion. And what I'm expecting you are all following our discussions, and also I'm extending my heartful thankful to you all to suggest for referring these references also. And thank you so much for your valuable concentrations. Thank you so much. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.